Sejam bem-vindos a mais um Pastelaria Podcast, o podcast oficial da Spektra. E hoje, tenho aqui ao meu lado, não é a Maria e eu não sou o Natan, mas eu tenho aqui ao meu lado o meu parceiro de laboratório durante muitos anos e agora também durante
Os anos que vão vir,
os
né?
próximos anos, o meu parceiro de relatórios e mesa, podemos dizer assim. Tô aqui com o Lucas. Oi, Lucas, tudo bom?
E aí, pessoal, pra quem não sabe, aproveitando essa deixa, eu e o Gabriel trabalhamos no mesmo laboratório, que o Natan trabalhou também. Então,
Isso.
nosso doutorado está sendo no mesmo lugar.
Muito frutífera essa amizade que trouxe a gente até aqui. Como vocês podem ver, provavelmente em episódios anteriores e até pelo visual diferente, nós estamos num lugar muito especial. Estamos aqui em Leeds, na Lhasa, e hoje nós vamos falar sobre o que, Lucas?
Hoje nós vamos falar um pouquinho sobre Purga. Então, vamos trazer aí, acho que uns experts de renome.
Pouca coisa, né? Pouca coisa.
Gente pequena aqui. E falar um pouquinho sobre Purga, como que a Purga se aplica, como nós fazemos um risk assessment de Purga. Ó, já estou metendo em inglês. O risk assessment é uma análise de risco de Purga.
E também como que a ferramenta utilizada pela LASA para avaliar essa questão da purga para impurezas mutagênicas.
Isso. Uma ferramenta que talvez alguns conheçam, o Mirabilis, mas a gente vai trazer um pouquinho mais sobre isso nos próximos minutinhos.
Mas antes de começar, a gente gostaria de mostrar para vocês os nossos parceiros que estão patrocinando a gente. E vai agora para os recados.
Os recadinhos estão um pouquinho diferentes hoje, porque a gente acabou não conseguindo gravar os recados lá, porque o tempo de gravação era curto, e a gente acabou otimizando o tempo para gravar o máximo possível para vocês. Então, vamos lá falar com nossos parceiros, recadinhos dos nossos parceiros, começando pelo Sérgio, da Axios Research. Você sabe, não tem ninguém aqui para me corrigir, tô sozinho, posso falar errado à vontade. E se você quiser padrão, vai lá, Sérgio! Vem no podcast, na Castserie, vira lá na pastelaria, o pessoal da Spektra. Quero padrões. Dá desconto? Dá aquela condição marota de pagamento? Manda para nós, manda para o Sérgio, vai ganhar brindes, vai ganhar descontos, vai ganhar condição boa de pagamento. E se você quiser amostradores de pó, líquido, viscoso, é com o Sérgio também, que ele é representante ele é parceiro da Sampling System, que é a primeira empresa de amostradores do mundo. É uma empresa inglesa, boa demais, vai lá com ele, pega tudo isso aqui, faz um pacotão, pede desconto, pede forma de pagamento, pede parcelamento, pede tudo para ele. Não sei se você vai conseguir. Mas fala que veio aqui que pelo menos brinde, eu garanto que você consiga. E nossos parceiros da YMC, que vai te ajudar com colunas cromatográficas, você vai lá falar com a Marina, com o Laudo ou com o Lucas, fala com eles, fala, meu equipamento está com problema, e eu não sei qual coluna que é, eu não sei se essa coluna que está usando aqui é boa, me ajuda, me dá coluna boa, vem aqui fazer um treinamentozinho, um workshopzinho, vamos alinhar tudo, então você vai lá e tem contato com a YMC, todos os links estão aqui na descrição. E mais importante, está acabando o ano, falta pouquinho, e a gente não bateu a meta dos 3.000 inscritos no YouTube. Então você vai lá no YouTube, divulga para todo mundo, faz aquele mutirão de divulgação do Pastelaria, divulga para todo mundo, amigo, pede para amigo divulgar para alguém, pede para seguir. Não é só divulgar, a pessoa tem que seguir também, né? Tem que dar aquela moral para a gente para ajudar a bater a meta. Você vai no YouTube, pastelaria.com, ou no Instagram, Spektra Soluções Científicas, ou no LinkedIn, Spektra Soluções Científicas, ou do Spotify, Passaria Podcast Oficial também. Você vai lá, segue, compartilha, curte, que é muito importante pra gente. Não esquece do nosso site. No nosso site tem todo o conteúdo para você ir lá, tem blogs, temas diversos, cada 15 dias, cada 15 sexta-feiras, 15 sexta-feira não, né? Cada 15 dias, toda sexta, após 15 dias, ficou confuso, mas você entendeu? Não é toda sexta, mas a cada 2 sexta-feiras, para facilitar a vida, tem blog que a gente escreve lá sobre temas diversos. Tem a playlist, porque às vezes você não consegue acessar o YouTube da sua empresa, tem a playlists com os conteúdos do podcast, então você clica lá e assiste sobre nitrosaminas, QBD, QBD e a porrada de coisa que tem. Você deve ter lá 10 horas de nitrosaminas, se você ouvir tudo, ou mais ainda, viu? Então você vai lá e dá aquela moral pra gente. Agora, eles vão falar inglês, porque o Chris fala inglês, não fala português, e é a maneira mais fácil de fazer o conteúdo. Mas o YouTube vai te ajudar. Se você está vendo isso ouvindo no Spotify e não está com o inglês apurado, talvez você perca um pouquinho. Tenta trabalhar esse inglês aí, ajuda a gente, não é por isso que você vai abandonar nós, né? O conteúdo é muito bom, São pessoas incríveis que estão lá, então vale a pena o esforço. Eu vou mostrar para vocês aqui, ó, como é que faz essa legenda automática no YouTube ou colocar dublagem no YouTube, tá? Vou mostrar para vocês e aí depois você segue pro vídeo, bom vídeo para vocês. Beleza? Bora lá. Você tá vendo a tela do YouTube aqui, bonitinha, vou gravar a tela para vocês verem. Vou dar play aqui no vídeo. Cadê o playzinho? Tá falando em inglês, sem nada. Você vem aqui, ó, nesse botãozinho aqui, ó, legenda. Clicou em legenda, a legenda já aparece aqui, ó, no idioma que você escolhe. Você clica aqui na engrenagenzinha, idioma da legenda, inglês, português. Você tem traduzir automaticamente, ou você escolhe a legenda que ele vai traduzir, tá bom? E funciona bonitinho. Aí, o segundo passo para dublar, eu vou até apertar pausa aqui, ó, para você entender. O segundo passo para dublar, você tem que instalar a extensão. Então você vem aqui, o link da extensão é esse aqui, ó. Speak Subtitle for YouTube. Eu vou colocar essa descrição esse link aqui na descrição do canal, tá? Instalou essa extensão, atualizou a página, vai aparecer esse menuzinho aqui, ó, à direita, lá direito. Então o que você faz? Você liga ele, ligou, escolhe quem vai falar, qual idioma que você quer que ele legende não, traduza, né? Duble, muta o áudio original e dá play. Olha só.
Química molecular pela primeira vez. Sim, quando vi as moléculas se movendo, pensei, isso é incrível. Preciso colocar isso no meu portfólio também e no meu projeto, porque preciso.
Então, além de assistir e ouvir ele todo em inglês, entender inglês, coisa linda, mas você tem essas duas opções, ou legenda ou dubla, que você consegue acompanhar esse podcast bonitão. Desculpa tomar tempão nesse, mas é o primeiro da Castserie. Vai vir uma série de conteúdos em inglês daqui para frente, junto com os conteúdos em português que a gente sempre faz. Então é isso, espero que tenha gostado, espero que ajude e bom programa para vocês. Tchau!
Bom, pessoal, agora então nós vamos trocar um pouco a língua, porque nós estamos com convidados excepcionais aqui. Então, espero que vocês aproveitem esse episódio e vamos pro inglês agora. So, we are here, back in the game, now in English. And we have two exceptional guests today to talk about Purge Factor and also Mirabilis. And we want to introduce you them. And it's kind of hard to ask the question that we always ask in the beginning of the podcast. That is, quem é você na fila do pastel? So would you like to explain to our audience, Lucas?
Yeah, so we tried to translate it to who are you in the pastel queue. Not everybody got it because they don't know what a pastel is.
Yeah.
So it's been quite hard. But we did our best to make our guests comfortable so they know at least what we expect from this question maybe. So I'll start asking Mike Byrne then. Who are you in the pastel queue?
So I'm Mike Burns. I'm organic chemist by training. Been with Arthur now for coming up 10 years. And it's been a long while. It's flown by.
Yeah.
But yeah, and I'm all about the purge calculations and nitrosamines now as well.
Yeah.
And I also want to say that yesterday we played paddle.
Yes, we did.
The audience in Brazil probably won't know what paddle
No,
is.
they
but
do. It's quite popular right now.
It is?
It is.
I know
yes.
that beach tennis is quite popular, but
Yeah,
I
but
didn't
now-
know that.
Paddle too.
Yes,
Really?
Pedro is coming with
Okay,
that.
so now that I know that you know that paddle, what paddle is, so Mike is a monster playing paddle.
It was my first time. I wouldn't go that.
Really?
Yeah.
Really? Okay.
I play tennis, so it's
Oh, okay then. I was struggling I was Mike's partner in the game, and I just let him hit all the balls because I wasn't able to even see where the ball was. So yeah, it was incredible.
I struggled with the lack of spin.
Yeah.
Sent a few into orbit, but other than that, it went pretty well.
Yeah, but I think we got all balls in the end, so
We were about there.
Yeah, we didn't lose any, so that's good for the place.
Yeah.
Yeah, it was good fun.
Yeah.
People told me as well that you are actually an excellent football player. Is that true?
Oh, not really. That's overstated. I've got a decent shot, but that's pretty much my one trick.
Okay.
Hit it really hard.
Yeah. We should schedule a game.
Yeah, that would be good.
And about your background, where did you do your college? It was here in UK.
Yeah, so I did my undergrad degree at University of York,
Uh-huh.
and then
Yeah,
actually
sorry, chemist.
in chemistry, yeah. And then I got on really well with one of the academics there who I did my master's project with.
Mm-hmm.
And then I was just beginning to work out what do I do next. And he said, I've got a PhD going if you want it. And I was just like, yeah, why not?
Yeah.
Just, yeah, let's
Uh-huh.
stick it out a bit more. I love York, so like stayed there for a bit.
And what was your PhD?
So it was a total synthesis project.
Total synthesis. Okay.
Yeah.
Can you disclose the molecule or?
Yeah, it was Facilocarpus 2-pyrone.
Well, yeah. It's undisclosed then. So.
Cheer,
Good
please.
luck, audience.
Completely useless, but it was a nice sort of academic challenge, right?
Uh-huh. Yeah.
The idea was to try and use palladium chemistry as much as possible to put it together.
Uh-huh.
I learned a whole lot about what we couldn't do.
Oh, okay, yeah.
Yeah.
My PhD was the same. Yeah.
Most PhDs, right?
Yeah.
Fortunately, the guy who took over my project after I left, he actually then did it because I'd clearly told him everything not to do from that point onwards.
Uh-huh.
So he managed to complete that. So that eventually got made, just not by me. So yeah, I loved my time in York, but then
Yeah. And how old were you at the time when you started and when you finished?
so what was I? I was 26 by the time I finished
Uh-huh.
my PhD, and then headed into industry for a bit to get a new awareness of other types of chemistry that take place.
Yeah.
It-
So please go.
No, I would just say, I was just going to say that it's funny that here in the UK, people get out of their PhD so young. Like in Brazil, you are usually on your 30s when you're getting out of
Oh, really?
Yeah. Because you usually have to go through a master's degree before, and that's 2 more years. So we have a 5-year graduation program,
Right.
2 years of master's degree, then 4 or 5 years of PhD. And then,
Yeah. So without the degree I chose to do, it was 4 years straight to a master's. So there was no bachelor's at all. It was
already.
straight into a master's in 4 years. So start at 18, you finish that at 22,
Uh-huh.
and then a PhD is
Yeah.
3 to 3.5 years.
oh, right.
Actually,
Yeah.
yeah.
It's more like Brazil. I think US they took longer.
They take
Finish the
longer.
PhD.
Okay,
Yeah,
okay,
they
okay,
can.
okay, yeah.
They can take longer.
Yeah.
And then after your PhD, you went through some pharma industry.
Yeah, so I went to work for a contract research organisation
Yeah.
based down at Sandwich, where the Pfizer site is. So spent a few years there doing all sorts of different chemistry,
Yeah.
which was great.
Uh-huh.
Loved working in the lab. I think the biggest frustration as a contract researcher is you can pour your effort into something for a few months, really tricky
Uh-huh.
synthetic target, and you're like, yeah, got it.
Uh-huh.
And then that's the last you ever see of it.
Yeah.
Well, at least tell me if it was any good.
Yeah.
Like,
Uh-huh.
But to be fair, I mean, in organic chemistry, if you get the compound to
I mean, that is
Yeah, that's
I'm
a victory.
happy enough.
That's a victory. Yeah.
So yeah, what's quite funny as well is a lot of what we were doing was sort of med chem and like greater than 95%. Oh, that's great for an assay. And like, look what we're doing now, and we're all about the impurities. I'm like 95%. That's terrible.
Yeah. To see how the game changes.
Yeah, the
now,
game
right?
changed.
Yeah. And as after you finish this kind of contract job, you went straight through to ASA?
No, I went actually to another organisation. It was spinning out of a university. It was hoping to be a biotech startup company.
Mm-hmm.
All right.
Really interesting sort of cutting edge science. I was there as what I'd like to call synthesis support.
Yeah.
Making a whole range of isotopically labelled structures.
Yeah.
Oh, that's new stuff.
Yeah.
Uh-huh.
Like simple chemistry, like simple targets, but then they're like, yeah, but we want a carbon-13 there and a deuterium there. You're like, oh, that just got a whole lot more complex.
This is something crazy, but on a totally different topic. I'm always amazed how they can sell like deuterated solvents so cheaply. I mean, it's not cheap for us in Brazil,
Yeah.
but
Relative,
like
yeah.
you are taking hydrogens and making the thing like it to me is amazing.
Yeah.
Yeah.
But that was really cool because it was all about making organic molecules as MRI contrast agents,
Uh-huh.
Right,
where you could get, like, if we could get it working perfectly, you could get an MRI scan of a person's brain in like
Yeah.
5 minutes in
Uh-huh.
what would take overnight now.
Yeah.
So
Yeah,
it was like, if it worked, it was going to be a complete game changer.
Definitely.
did it work?
Partially.
Yeah. Okay.
Oh yeah. Well, I mean, from
It's not changed the game yet.
Yeah.
You know, it might do one day. And
Yeah.
I was there at the beginning, so.
and if you, I don't know, maybe get something that works for not 5 minutes but for 1 hour, it's better than
Yeah.
overnight. So yeah.
So if you think of NMR at the minute, you're looking at, what is it, 1 in 100,000
Shifts.
sort of differences between spin up, spin down.
Uh-huh.
We got it to 1 in 3.
Cool.
So like the sensitivity was through the roof, and we
Uh-huh.
could get it to last like 5 minutes,
Oh,
which was pretty good.
yes.
But the big problem at the time was it didn't work if it came into contact with iron.
Okay.
There's a small problem with
Yeah.
blood there, right?
Uh-huh.
So I know that the work's ongoing there, looking at different targets instead that won't have the same problem. But
Uh-huh.
yeah, it was dead interesting.
Yeah, it is. It is like I never met someone that worked with labeled compounds.
Oh yeah. We just work
Like
with.
personal, I
yeah.
just read about it. So yeah,
Yeah,
it's pretty
yeah.
amazing.
It was funny working as an organic chemist, working for an NMR chemist.
Yes.
Yeah,
it's
yeah.
true.
He had no concept, so I was given largely free reign along with one of my.
And I guess that you also got in contact with a lot of physics in the process, maybe.
Yeah, too much.
Yeah,
Lot of-
more than you would.
And I did.
You pick up quite a lot, but yeah, it was good.
And how did you get to us after that?
So it was around about time that sort of contracts were running out, and like my wife was pregnant at the time, so
Okay.
I needed a bit of job security. I needed something. So I was just looking in the area, and I saw this company in Leeds. Never heard of them. I put a CV in, not really knowing what the job was.
Uh-huh.
And then, I got the job, and I'll be honest, still wasn't entirely sure what the job was. I took it anyway, and then, it's worked out pretty well. I've been here, as I say, nearly
Yeah,
10 years now.
but it was a huge shift. Like you were always bench lab person, and then came to a company that is more theoretical chemistry.
Yeah, so that was a big part, actually, of the deliberation.
Uh-huh.
I was sort of chatting it through with my wife, going, but I don't want to leave the lab.
Yeah.
She's like, but you might have to.
Yeah.
So, I've tried to convince Chris, the CEO, a number of times that maybe we should like put a little extension at the top where I can just have a little lab to dabble in, get some extra results.
Yeah.
Maybe at a foam hood somewhere.
Yeah, just a few, little LCMS somewhere.
Uh-huh.
But yeah, it's not really realistic.
Yeah.
But yeah, I love the lab. I don't think I was ready to leave the lab, but at the same time, I don't know that anybody who truly loves doing the lab work is ever
Yes,
ready
forever.
to leave.
Yeah.
Alright, so
I had a professor, Nathan also had this one in Chicago. He's a old, very old school professor, chemistry. He goes to the lab every day and synthesize everything, and he always asks me like daily, do you think I'm too old for doing this? And I was like, yeah, not until you ask me, but yeah, now that you ask me, maybe. But yeah, it's amazing experience to be in the lab. We all been through this.
I think it's the camaraderie in the lab as well. I always loved everywhere I worked, I really enjoyed the people I was working in the lab with, which makes it such a fun environment.
Yeah.
Rather than just sitting behind a computer. You get used to it.
You have to deal
and
with
then you do all the Teams meetings.
Yes.
Come into the office instead. But,
Uh-huh.
but yeah, I think that sort of camaraderie that you get in the lab, that was the thing that really, I think that was the turning point for me for wanting to follow research, was during my master's project, that environment of being in
Uh-huh.
a good team,
Yeah.
working in the lab,
Yes.
and sort of advancing the science. It was just like, oh yeah, I love this. So yeah, that was probably the big thing for me.
Uh-huh.
Oh, but if there's one thing that I don't miss from the bench work is smelling like solvent when you get home.
Yeah,
Yeah. Yeah, this is something that I don't regret.
don't miss
I
that.
don't miss
Yeah.
that. Yeah.
Yeah.
Yeah, I think I did a lot of smelly chemistry as well during my PhD. I think there was one week or 2 weeks where I had a run where I was doing Swern oxidations,
Uh-huh.
making butyraldehyde.
Oh
So-
yeah, I've been through
So,
that.
like,
My professor, I know this now. Yeah,
and they
it's
just-
awful. Yeah.
I've got butyraldehyde reactions going over here, and I've got Swern oxidations going over here, and just everything stank.
Oh, I don't know.
Yes,
No way,
yes.
no way. I've never worked with anything really smelly. My things were pretty well behaved.
Yeah,
Yeah.
and it just such low levels that you need to get the smell. It's like you'd have the fume cupboard as low as you possibly could, getting your hands under to.
Oh, we had a trap a trap system that you had to put all gas through a small tank with what's the name of the água sanitária?
Oh,
Bleach.
the-
Oh, yeah, you had
Uh-huh.
you had to put all gas line through bleach.
Yeah.
Then the lab won't smell if you're working with anything smelly. Yeah.
But it just sticks to the glassware. It didn't seem to matter. You'd
yeah.
have to have a bleach bath in the back of your cupboard just
Yeah,
before you can even wash anything up. You've got to leave
Yeah,
it for like
we-
2 days.
Yeah, we had to bleach all glass. All glassware was also bleached after. Yeah, it was terrible, but yeah.
And we also have here our Brazilian British guest. Our
Not so British.
But very Brazilian.
Very Brazilian for sure.
yeah, Roberta. Oh, Roberta. It's hard.
It's hard.
No?
Yeah.
We say Roberta, but we need to say with some English intonation, like Roberta.
I'm saying Gabriel here a lot. Yeah.
Yeah. So Roberta is more used to our question. She probably had many pastéis in her life. So Roberta, who are you in Pastel Kiwi?
So at the moment, I am a person that is a bit nervous because I am here with you today. So in this amazing podcast that I used to hear for a long time since the first episode. So it's a pleasure to be here. Thank you for inviting me. And my name is Roberta. I am from Brazil. That is an important thing to keep clear because my English, you may
It's better than ours.
you understand a little bit better than Mike. Mike is from the accent in New York is heavy, but I will try to do a good work today. So I'm from Brazil. I am from Rio Grande do Sul in Brazil, and I get my undergrad there, my undergrad degree there in Universidade Federal de Santa Maria. And I did my master degree there as well. Then I moved to Campinas, to Unicamp, and I started to work with Professor Pili in organic synthesis. So I did all my formation, all my first years in chemistry as organic chemist. And I work with methodology different from you, Lucas. I have worked with smell things, and in my undergrad, I used to work with selenium.
All
So-
selenium compounds are.
There was
Terrible,
one day that I arrived in the class and my teacher arrived to me and said, "You don't need to stay. I will give you the tip that you was here. You can come back to the lab." I was glad because the smell was really strong. So
Yeah.
and in my master degree, I worked with methodology, but my PhD, I used to work with total synthesis. So I was trying to obtain a molecule that was cryptomoscaton. It was
Well, today's the day of the third molecule.
Molecules, yeah.
strange names, but it's a natural product extracted from a university in Brazil, and our goal was determine what was the stereo centers in this molecule. And of course, as a good total synthesis, I didn't finish it.
Yeah.
So,
Yes.
but my group finished a few years later, and we now discover what is the stereochemistry.
Just as a question, were you using selenium as a catalyst, or was it in the molecule?
No, it was in my undergrad when I
Oh, in
was-
the undergrad. Oh, okay.
Like,
okay,
yes,
okay,
yes,
okay.
yes.
Yeah.
Yes, in iniciação
All right,
científica. I don't know how to say this.
It's like a scientific initiation.
So you are an intern during your
undergrad.
Yeah, you have like a research project,
Yeah.
Yes.
Yeah.
depending on what level.
So we prepare desalinate compounds and use as catalyst. In my case, I was working in a project where we were doing one form Michael addition
All right.
with mediated by magnesium
Mhm.
in an asymmetric way.
Mhm.
It was one of the first good results in these areas, by the way. It's very interesting. I used to work with Professor Antônio Braga when Braga was in Rio Grande do Sul, not in Florianópolis yet. So we work with this. I was part of a PhD project, so there is a main researcher, and I was there to support him. And I was doing all these smelly reactions
People loved you at lab.
and generate AGCL in the lab. So I was doing all this kind of job. And in my PhD, I was working with asymmetric synthesis as well. And I use a lot of Swan reactions. I love Swan. And Swan is my favorite reaction, actually, because you can see all the mechanism of the reaction when you are preparing. So you put the first compounds, you know that there is a proton abstraction there. And then when you put triethylamine, you know what is happening in each moment and in each temperature. So I love this reaction because it's almost like you can see the molecule in the round glass.
It's like optical spectroscopy.
Yeah.
And the smell. If you have a bad smell by the end, it's working.
Yes.
Oh,
So-
that's so
Nice.
yeah.
All my lab
You use your own NMR to make
Yeah.
sure. Yeah.
Yeah.
All the lab was upset and I was happy all the time.
Yeah.
It's my favorite reaction, Swan.
I don't think I've ever had a Swern like be unsuccessful, unless you've just rushed it. But
Yes.
actually,
It's an easy reaction.
it just always seemed to work on whatever target. It's such a good reaction.
Well, I never did one, but my favorite one is the Suzuki coupling. Oh, it works almost every time. You can get very high yields, and it's so easy to purify. Like I always got like close to 100% yield, and I didn't need to purify it any further. Yeah.
In my postdoc, after I finished my PhD, I started to work with palladium. So I did some Heck Matsuda reactions in Professor Carlos Roque labs at Unicamp as well. And the reactions that I was doing was very good. So I love cross-coupling because it really works.
Yeah.
Yes.
Yeah.
So much easier than the reactions that I was doing my PhD.
So you're also a chemist?
Sorry?
You are also a chemist.
Yes, I am industrial chemist.
All right. Okay.
Yes. And it is funny, I can say, because when I did my undergrad in Santa Maria, there was only to be a teach in chemist or industrial chemistry. But the focus was more to be a bachelor, not work actually in industry, and
Like
we
a
change it
academic
with time.
Career.
So yes, they prepared us very well for academic career, and I followed these steps for a while.
Oh, but now I'm gonna make a huge jump. And do you think having a background in industrial chemistry makes you a better researcher here when we are talking about purge?
Yes.
Yeah.
Yes, but not only because of my undergrad, but when I finished my postdoc, I was a year only. And after that, I started to work in the private education in Brazil. And at this time, I was teaching about organic process and industrial process in general in a university. So the knowledge was always fresh in my mind. So now when we started to discuss purge and when we needed to create a process and use examples, it is easier for me because I have this background
Yes.
with unit operations. So yes, helping a lot.
Yeah, this is something that we don't have, me and Gabriel, so we had to, we have to try to understand in a different way. So we have to read a lot to really to understand how an industry, a chemical industry, work, because this we are used to the lab, and the lab is
Small scale.
Forever.
Yes, different. Totally different.
Yeah. And how did you end up here? at UK Lhasa.
Yeah.
And the pharma areas.
Yes, precisely. Yeah.
I was working in private education, and I had
Teaching chemistry? What was it?
teaching chemistry.
Chemistry, yeah.
Yes, a lot of different kind of chemistry and statistics. So
Oh, really?
Okay.
Oh, so, yeah.
This
You're all Alberta? Yeah.
Talking to the
I'm
guy.
sorry,
Yeah.
my students. I was a terrible teacher in this area. I'm sorry for that. But I compensate in general chemistry and organic chemistry.
Yes.
So, after stay a while teaching, I decided to move to the pharmaceutical industry. And then I joined the generic industry in Brazil. And I think that it was the most important to support me here in Lhasa now is to know how the process in the industry happens and how we develop a product in the industry. So where I worked, it was a school for me. They are great doing their jobs and I have learned a lot. I had the opportunity to start to work with impurity. So I became from look to the principal product to the impurity. And that was the biggest change in my life. And I have learned a lot. I have learned about purge and I have learned about impurities in general and a lot of every disease in Brazil, ICH guidelines. So it was a life change for me. And I am a person that I don't like labs. So I prefer the theoretical studies. So I was
So
totally
you're at home.
totally at home. And I was building a good career there. But then my husband received an offer to move to UK.
Interesting.
And at this time, I already know Lhasa and I was totally in love with Lhasa software. And I said, good, because Lhasa is in UK. Maybe one day I can join Lhasa too. Yes, let's go. Let's move to London. And we did. After 1 year starting our life here and being more supportive and work as a consultant, I decided to apply to Lhasa. And I was totally afraid about they don't accept me because it was my dream work at Lhasa. And then I was totally afraid about they accept me. And I said, oh my God, I don't have the knowledge. I don't have what it needed to be part of Lhasa. So I was totally scared. Then in 1 week, I sent an email to Krina and I was here doing my interview. And when I put my foot here, I was so comfortable because I was walking in the opposite and there was a lot of organic molecules. And I said, I am at home.
Yes.
And then we have the interview and I come back to London with an offer from Lhasa. And I am here 2 years, it was 2 years ago.
2 years ago, yeah. Okay, that's amazing. It's inspiration for everyone in Brazil.
Oh, yes, that is important to mention. We have a very good knowledge in Brazil.
Yeah.
Very good. Our organic chemistry in Brazil is very, very strong. And the pharma industry in Brazil prepares us a lot for the real life. So
yes, yeah. I think that we both had the same experience of working at the lab in Brazil and then working in the lab outside Brazil.
Oh, yeah.
And then we can see the difference and how we are prepared to do it because we are constantly struggling with different kinds of issues that we face daily, like small things that will take a few days from your work.
Yeah.
And you don't see this happening outside Brazil. And so...
Yes, I needed to use Portuguese word, sorry Mike, is jeitinho brasileiro. Is the way that Brazilian people can sort problems is different in the lab. I worked 1 year during my postdoc in Germany. And one day I was looking for a Ruby to dry some samples. And my colleague said, oh, I am with the last one of the lab. If you need, I can give you because I am using 3. I said, no worries. So I took oh my God, I forgot the name in English. That you use it to filter.
Funnel?
Funnel. Of course, the same with the Portuguese. Always happens. So I took a funnel and I put the air and I just put my samples here with the funnel and said, oh my God, it's a life changing. I never thought about it. And I said, yes, we needed to sort this kind of issues all the time because we don't have equipment, we don't have the reagents, so we needed to think in an alternative. So we learn a lot in Brazil to survive.
Yeah, we do a lot with very, very little. Yeah, it's something.
Yes.
Yeah.
and now changing a little bit, but not too much, is kind of contradictory. I think that back in the time when we were synthesizing our molecules, we used to not care that much with the impurities. All we wanted was the final product, or even the intermediate. And now we're here at LASA, at Spektra, consult LASA, and we are assessing impurities. We're assessing impurities formed during the synthesis, how we can remove them, how we can assess them, make a risk assessment. And it's all about this episode today. And could you guys give our audience a brief introduction of what a purge is?
Yeah, I can go, yeah. So, purge, in terms of the purge calculations, is just sort of a semi-quantitative way of sort of assessing whether or not an impurity is likely to carry through a synthesis. It's not fully predictive, but it gives you guidance of how likely it is to still be there. It tends to underpredict the actual true levels. That was built into the predictions.
Yes, this is perfect. This is exactly
that's
what
the
I
key
want.
point,
Yeah.
right? Is it's not what you're not doing is you're not predicting exactly what level you're going to have. You're almost predicting it won't be more than this.
Yeah.
And actually, by doing that, just almost as a thought experiment to start with, it can help guide you through the next steps of, right, do we have enough controls in place? Do we need to get some data to support the purge calculation, or do we need to change the sourcing material of a starting material because the impurity within the starting material won't be purged? And these are the sorts of things it can do. It can help guide you, and in fact, if you use it earlier on in your process, you could even start to understand it even more and be like, well, let's add an extra unit process in here or there to make sure we have the control, rather than get into the end going, we've got a problem. Because it's the analytical, right? Every pharma company at the minute, especially, the analytical department's completely overrun. So the more you can focus that resource in the best areas, the more effective your delivery is going to be.
Yeah, and we also we are also thinking about cost, right? So
And cost too, yeah.
Yeah.
Never completely rule out the cost.
Yeah. If you can guarantee in a way of a risk assessment that this impurity will not be there, so it's one thing less that you gotta look for. So
Exactly.
Yeah.
But by the end, it's about safety.
Yeah,
Purge is about safety, because when we are doing synthesis in the lab, we do not worry if impurity can be formed. We only need a good NMR to use in our thesis, or to check if the reaction is possible. Wherever you need, it's just a general overview. But when we are in the industry, we need to make sure that even in small levels, the impurity is not present in the final API, because someone will use this API in a drug. So we need to make sure that the impurity isn't there. And during the organic process, during the synthesis process, it can happen that the impurity can be removed across the process. So you put a reaction, and then you do the workup, and then you do an extraction and remove solvent. During these steps, the impurity can volatile can be purged.
Yes. Get away.
Some days we have difficult words. I'm sorry for that. And you can wash the impurity, so you can do a lot of process. And
But a lot of these, they're there for that reason in the first place, right?
exactly.
Yeah. So the joy of the purge calculation is the fact that it allows you to convey what you already know in most instances of, well, we did that crystallization for a reason.
Yes.
It's always about
specific step.
we're always seeking a clean product at the end. So there's a reason we did an extra wash. There's a reason we did an extra recrystallization.
And are purge calculations applicable to all impurities, or would you say there is some caution?
No, I mean, they're specifically cited in M7 for mutagenic impurities, but if you think realistically, if we're using them for the worst case scenario, why aren't we using them for
Yeah,
for others as well?
Yeah, that's the way of thinking. Yeah.
I always answer these questions. You need in the way that you need to think that we are talking about molecules. So all the molecules has a boiling point. Sometimes they degrade before boiling, but there is a boiling point. There is solubility from different molecules.
Yeah.
And we are not talking about a specific class. The only thing that you can observe is that mutagenic impurity are normally mutagenic because can react more with DNA. So the reactivity will be more important, will be contributing more in the purge than in molecules that are not so reactive.
Yes.
But of course that you can wash, you can evaporate, you can do everything in the unit operation. So yes, you can apply to all the impurities. But of course, we expect a different behavior when we are talking about impurities that are not so reactive.
Yes, yeah, definitely.
And I think we've seen it already, right, with the nitrosamines, because one of the best ways of de-risking the nitrosamines.
You killed one of my questions.
It's impossible not to talk about nitrosamines.
We can't avoid them. But this is one of the great ways of using purges to de-risk the formation at a level by tracking the amines themselves.
Yes.
The amines themselves aren't mutagenic. It's just what they might fall is of concern.
Yeah.
But we're actually using the analysis of the amine, which is non-mutagenic, right? So we're already using it for non-mutagenic impurities already.
Yes, that's true. And you talked about purge calculations. Can you give like a brief general perspective?
Yeah, so
Calculations.
So the numbers are fairly simple, easy maths. So the highest possible purge you can score is at 100 for reactivity, because this is given that we think the reactivity is the biggest problem, we know they're highly reactive. And that essentially means that if you've started with 100 ppm, say, at the end of that process, you would divide that by 100, so you'd be left with 1 ppm. So purge factor of 100 equates to removal of 99%, if you put it in those terms, or at least 99%. But it's also important to remember you've also got other factors as well, which the volatility, the solubility, and although they're strong contributors, we don't score them as highly. So it might be the highest of 10, which equates to 90%. If you do the 100 divided by 10, you're still left with 10 ppm.
Yeah.
And these numbers were established by Entities Dale publication, and we can put in the subtitles of this. Episode.
The descriptions, the video guy is doing this already.
The seminal reference in the area that was the first tentative to standardization to how to measure purge. And this article is cited in ICGM 7, so they nominate Tisdale article as a guideline to the best way to evaluate purge using these scores.
Tisdale article here appearing right now.
Yeah.
Somewhere here, maybe in a card, maybe down there, we don't know. Leandro knows, so...
And Mike mentioned 100 for reactivity, so we can give you 110 and 1 for reactivity. For solubility and volatility, we can do 10, 3, and 1 as scores. And of course, you can evaluate other process that you may have. There is the full table in Tisdale article and how to provide these values.
Is there a reason why reactivity is the main contributor for purge factor? Like you have, for all of them, you have a max of 10 in the purge calculations.
Yeah.
Why reactivity we got 100?
Well, it's mainly because most of these impurities are introduced specifically for their reactivity.
Right.
You're not going to put something in that's only going to react to 90%.
Yeah.
You're putting these things in. Again, it comes back to cost, right? You put in as little as you can to get the maximum amount of yield, which means that essentially you're expecting it all to be consumed.
Yes.
Yeah, exactly. Yes.
So that was why that was part of Andy's original assessment, is that these things are mutagenic because they're so highly reactive. So we should reflect that. And 100 seemed like a sensible number. You expect 99% to be consumed.
Yes.
It's obviously not always the case because chemistry's never quite that simple. So,
Oh yeah.
And
yeah, like
you might be using it in excess as well.
yes.
This
yes,
would be
exactly.
like
Yes.
But again, you're using it in excess for a reason, right?
yes.
Because the side reactions going on, they're highly reactive.
Uh-huh.
So it's just a simple way of capturing that. Yeah, this is the core expectation that they will, and that was actually confirmed. There was an industry paper by the IQ group a few years ago where they surveyed all the different people who would be using purge calculations, and they saw that the biggest contributor to purge is the reactivity,
Uh-huh.
followed by the solubility.
This survey is very interesting because also you can see that purge concept can be applied for impurities class 1, class 2, and class 3.
Mhm.
So with no distinction between these three classes.
Sorry, we are talking now about Kramer classification, or
No,
are we talking
about
the
M7
CH? M7? Okay, right.
M7 classification. So you can use to all the impurities, mutagenic impurities, class 1, class 2, class 3, and also demonstrate that purge is well accepted by regulators.
Mhm.
So around 75% of the submissions surveyed in this article involved purge in the discussion, the control discussion.
And about the solubility, I always have this question. It's about the general solubility or the solubility that this impurity is inserted in, like the media of the solvent that is being used in that step.
It's the solubility in that solvent that's being used in that step, but also in comparison to the API that it's,
okay.
Yeah.
or the intermediate of that stage.
Mhm.
right?
So you can kind of separate them.
If you're doing a liquid partitioning
Uh-huh.
and you predict that it will be highly organic soluble,
Mhm.
but your API is in the organic phase,
Yes.
then you're not purging anything at all.
Mhm.
Therefore it's about that consideration of how soluble is it in the process solvents, but also having that thought of, but where is my intermediate going? Because it's about that separation from the intermediate or the API itself.
And here it's impossible to not talk about Mirabilis because we have, so Mirabilis
Yes,
is
please.
our
Yeah.
tool in LASM,
Uh-huh.
and Mike is our main scientist to work in Mirabilis. I used to work as an application scientist in this project and take part of several discussions and how to develop the product. But Mirabilis is more than a purge assessment tool. So it's a tool that supports us how calculate purge. And one example is when we are doing liquid-liquid extraction, we have a calculator in Mirabilis that can tell you, based in the conditions that are using, if your impurity is ionizable, nor ionizable, and if forms a cation or an anion, what phase the impurity will be.
Yeah.
Because it's related with pH and everything around the ionization process. And we have this calculation in Mirabilis, so you only need to input there the information that you have, and the software will provide you, based in the partition coefficient, what is the phase, what is the layer that the impurity will be, and you can check if it's in the same than your API or intermediate of this step. And you can choose the best value for solubility.
Yeah, and I think having a computational tool is perfect for purge because it's very difficult to standardize. If you're calculating by hand, it's difficult to standardize the conditions, and if you're taking everything into account, especially when we are talking about a long synthetic process, you have multiple steps, and when is this step important or not? So having a computational tool to make this decision and to be consistent in the decision.
So this is why we were originally approached. So the Mirabilis project was originated when Andy Teasdale and others in the industry approached us to say we think this needs a tool
Uh-huh.
to get that consistency, get that transparency. That it only works as an approach if the regulators accept it.
Mhm.
Yeah.
Yes.
And if
That's base level.
that's
Yeah.
base level.
Yeah.
And the barrier to regulatory acceptance in many ways is that consistency in that transparency of where the numbers have come from, how they've been applied. Having it all based within a tool just sort of ensures that level playing field, we can try and guide people through the best practice. The forum of members as well has actually been really valuable to sort of act as a forum to discuss best practice and identify where people are doing things differently and sort of almost harmonizing that approach.
Yeah.
So that's been a really big part of the Marvelous project as well, is that engagement.
And it's important to mention that in Purge, we need to justify the values. So we need a scientific background to use a score of 100 or a score of 10 or 3. Only one we don't need to use because there's no Purge. And Mirabilis is a software that facilitates this process.
Yes, yes.
So we need to be constant, and Mirabilis can do it.
Yeah.
And we need some background, and we have a fantastic knowledge base building by our science team at LASA that is able to do it.
Yes. Do you think that the most tricky part of Mirabilis, I mean, the building Mirabilis, was to assess the solubility of the compounds?
Yeah.
Solubility 100% is the single hardest thing, because I mean, in part in terms of predictivity, there's no good data sets to learn from, right?
Yes.
And there's also so many subtle variations of, it's not soluble in, I know, THF, but it is soluble in 2-methyl THF. Oh, where's that come? Anybody who's worked, like, it is difficult. So we're not there fully on the full predictivity, but we can get you most of the way there. And if it turns out that is hugely important as a process, as a purging step in your synthesis, then actually that's the point where you get a little bit of data to support the purge calculation, to say, look, we scored this, actually that was fully valid, and then along with the rest of the purge calculation, that provides that confidence that that's appropriate. But yeah, solubility is a nightmare.
Yes.
There's no unified source.
Yes.
But one thing that Mike already mentioned that we work with are the best practice. And for solubility, we had one paper, Mike's paper, that talk about solubility best practice that is very useful to whom.
There we go.
Yeah.
Yes, for you.
Video boys.
Yes.
Yes.
Yeah.
And this paper is amazing. And one thing that we try to do, and here I'm talking more about my application scientist side, we try to training our members that sponsor Mirabilis about the best practice. And it's a challenge because we need to standardize the approach about how to use Mirabilis in the best way possible and to get the best result. So what we will do is work a lot with best practice, and we discuss with our members to understand what are the challenges and how we can address these challenges inside Mirabilis.
Yeah. And I have a question now, just circling a little bit back to nitrosamines, that you said that the purge calculations are applicable to nitrosamines because it's applicable to anything.
Yeah.
So when we were talking about an API like nitrosamine, do you think using purge calculations is a good idea, or
It's
are the
possible.
properties? Oh,
It's still possible.
Yeah.
Sort of a watch this space, really. We've just submitted a paper with some of our members sort of demonstrating application of purge for nitrosamines. And that does include an API nitrosamine.
Oh, that's
as
interesting.
one of the
Yeah.
examples.
because I would expect
I mean, it's going to be harder. Regulators are almost certainly going to ask for data to confirm that final synthetic stage. You still have all those processes.
Yeah.
And actually what we see with nitrosamines is solubility seems to be the key one, right?
Yes.
They're not the most reactive of structures. So that solubility is vital. But there's, in that final stage, you're doing so many recrystallizations,
Yes.
extractions, and things like that, that if you're only forming it at very low levels, and if it's CPCA category 5 or something like that, you might actually be able to control it and demonstrate control to an appropriate level. It's about, I guess, understanding what's the most amount that can form and what that limit is that you're controlling it to. They're the key factors.
Yes.
And at present, there will definitely be need for some data, but whether or not, if we keep using it and we keep showing that it works, maybe in time there'll be a lower demand for confirmatory analysis.
Yes,
Yeah,
yes,
that's really good to know. Yeah.
yeah.
But it's good to clarify that API like nitrosa means when we are talking about generating the synthesis, when we are talking about drug product, it's a bit different because the process that we do in the drug product normally doesn't involve purge. So in this case, we need to use worst case scenario population to check if there is a risk or not.
Yes,
Yeah.
And I think that in the industry pharma context, the Mirabilis is great because they have all their informations about their synthesis. But when we get to the consultancy area, like Ultilizá-La, we got some DMFs that doesn't show us all the information that we need to use Mirabilis, for instance.
Yeah.
It gets tricky.
Yeah, at which point that's where communication is sort of trying to get in touch with the manufacturers.
Yes.
They're the ones who have the experience of handling it. They're the ones that you need that knowledge of the process to be able to fully do it.
Yes.
Otherwise, you're just going to be taking a conservative call at every step.
Yes.
But it's interesting. I was DMF analyst for 3 years, so I know the kind of data that we receive. That's more general. We don't have temperature. We don't have exactly the unit operations that the manufacturer is running for that synthesis. So this is one thing that I always say about Mirabilis. Mirabilis can support you about what information you need to evaluate the purge of that step. So, for example, if you arrive to the manufacturer and say, share all your process with me. They say, no way, it's my secret.
Yes.
It's my business, I can't. But if you say, oh, in this step, I only need the temperature that you use to remove the solvent. So much easier.
Yes.
But in our experience, even that sometimes
Yeah.
is difficult.
Yes.
There's an easy answer, right, as well to this, is that actually you get the manufacturers providing like a purge assessment alongside provision.
Yes.
That's if they can't do it themselves, we're here to support. But at least then, when that API is sold to however many different companies who want to formulate it, they're all getting a consistent report by the people who did the And I think that's something that, like certificate of analysis, that's commonplace. But at present, the sort of M7 assessment is not, and maybe that's something we should look to address in the future.
Yes.
Yes, and just to come back a little bit, Mike was talking about control options. So when we talk about control options, we are talking about M7 control options. We have 4 options of control. We have the control in the API specification that you need to run the test all the time that you produce a batch, and the industry that will buy your API needed to run the same test. And the option 2 and option 3, we are talking about control in the intermediate. So you create process control to make sure that that intermediate is pure. And option 2, you can use the safety limit as your limit. You cannot use more than that. You cannot exceed more than that. And otherwise, you need to disregard the batch. Option 3 is when you are considering a limit above the safe limit, but you calculate purge to demonstrate that in the API, the compound is safe. And the option 4, that I always say the best option, is the justification of the absence of control. And here, purge is the best tool to be applied because it's when you have all the scientific background to demonstrate that the impurity is not there. If you do batch analysis, okay, I needed to do the 3 sequential batches, but could be occasional.
Yes.
When you calculate purge, you are sure that all the batches you have a result under the safe limit. So Mirabilis is exactly for this, purge is exactly for this, is to calculate this. And we started to talk more linear, that you needed to assign scores and come back to how purge is calculated. What you need to do is evaluate all the process for one impurity, repeat for the second and the third. So for each impurity, we needed to evaluate all the steps in the same, all the steps, and to each step, all the workups, and we're building a table. in general lines, assign scores for each process. Once you have obtained this value, we need to multiply the lines and the columns to arrive in the predict purge. And the predict purge is the prediction about how we will start. You know how we will start, and the predictions about what is the level of the impurity in the end. So with the example that Mike gave, it's 100 ppm, you divide by score 100, you arrive in 1 ppm. So what you need to do is not only for one reaction in one step, you need to evaluate all your process to get the final value. And this final value will determine if it is enough or not the purge for that impurity. But then we need to obtain the purge ratio.
Yeah, so purge ratio is something that was also sort of developed amongst the Marabus consortium with Chris Barber, our CEO, was lead author on that paper, basically laying out the foundations of what you need to support any option 4 type approach. Essentially, if you've got a massive purge ratio, more than 1,000 times more than you need, then if you just provide the calculation, make it clear how you've scored it, where the values have come from, then you shouldn't need any further data. If the purge is a bit lower, maybe purge ratio between 100 and 1,000, then you might want to start getting some additional data to support that. But when we're saying get data, we're not just meaning like the final data in the API. It's like you've got NMRs, you've got LCMS along the way that you can use just to support the values that you've scored, rather than a consistent get more data.
Yeah, maybe access solubility of some.
Exactly, you might have measured that. Where it's between 1 and 100, though, this is where essentially we're saying, right, that safety factor against whether or not it's been accurately predicted the level or anything like that. There's a built-in safety factor further of, all right, we're now quite close to the specified limit in terms of the prediction. So therefore, the support is more about demonstrating just how conservative the support, the purge calculation is. So you can then replace some of the predicted purges with some, or support those predicted purges with real data, analytical data. It might be trace data, spike and purge data, but that you take those analytical stages with the rest of the purge calculation as a whole, and then suddenly your purge ratio, once you factor that in, might now be above 100.
Yeah.
And therefore back to being option 4. So yeah, it's the key being that getting a little bit of data isn't the same as collecting data every single batch you make. So it's just there to getting analytical data to support what you've predicted, basically.
What I really like about purge is like the calculation is already conservative, and your decision in the end is also very conservative. So it's not something arbitrary. We are not just giving you a number and saying, "Oh, don't worry about it because I did some weird math here and it's fine." No, every single step is conservative. So in the end, you are pretty safe that the impurity will not be there, or it will be at a acceptable level.
Exactly. That's the key thing, right? And as Roberta said earlier, it's all about ultimate safety at the end.
Yeah.
And to get the value of purge ratio, we need to understand what is the safe limit. So we needed to understand what is the purge required. So what we needed to do is we have the initial concentration and we have the final concentration, that is the safe limit. We needed to make sure that's under the safe limit.
Yeah.
So this is the required purge. And if you calculate the purge for your process and divide for the required, you get the purge duration. And then you apply these values that Mike have mentioned. Again, other paper for today, Chris Barber paper, that is very educational and explain a lot how to do this calculation. It's very, very useful.
Yes. And do you have you been in touch with or reading a lot of DMFs that kind of does this kind of calculation? Or
I've not seen a DMF that provides that calculation. No.
Yeah. And what do you think
And
about
was it good?
It was a long time ago, just to be clear. So now we have advanced a lot in terms of purge discussion. So 6 years ago, there were some gaps that needed to be fulfilled, like how to calculate the purge ratio and what to do after get the purge prediction. So I saw a few DMFs with purge calculation. I couldn't evaluate if the purge was assigned properly,
Yes.
but they didn't know what to do with this value by then.
Oh, right.
And they took wrong conclusions about it. And as analysts, you need to come back and say, review, please, you needed to do this, this, and that. And here, I was using Chris Barber and Tisdale paper
Yes.
to address this question. So the main problem at that time was how to use purge. And again, Mirabilis came
Yes.
to be very supportive with
Yes.
this.
Yes.
Because once you are using Mirabilis, when we started the process, you needed to put the API daily doses, the worst scenario, of course, because we needed to be conservative. So if there is more than one dose possible, we will use the biggest one. And we needed to, when we tag impurities in the software, we needed to include what is the control that you needed to apply to that impurity.
All right.
So we only need to know about our process, about our impurity, and the API. And Mirabilis already treated the values for us. And you have this very well explained by the end in a summary table, and you can understand exactly how to take your conclusion. So Mirabilis is very supportive for whom is starting to apply purge, because you already know your process. You only don't know what to do with the numbers, and Mirabilis can support you on that.
Yes.
Definitely.
And I think what Roberta just mentioned there is about sort of circles back nicely to the earlier question about what types of impurities can it be used on. So ultimately, it's all chemistry
Yes.
and physics, I guess, as well. But because the required purge, that is dictated by your control limit. So the more toxic it is, the lower the control limit.
Yes.
Yeah.
Best.
And that defines the purge ratio, right? So if you'll just achieve the required purge much easier with something that's non-mutagenic in theory.
Yeah.
So it does circle back around there. It factors in the mutagenicity or general toxicity as part of the calculation, which is why we've not said it for 15 minutes, but that's why it can be applied to nitrosamines, right? Because it does factor in that super low limit that they need to be controlled to.
And assuming a CPCA 1 nitrosamine, then we're talking about very low limits, and if you can do a purge, way better than
Try to test, yes.
You probably already saw in some DMFs.
Yeah,
impurities,
I was about to say that.
impurities that never was observed. You request batch historic reports, and there was 100 batches, and not even in one the impurity was observed. I always ask why they are controlling this impurity. There is no reason to be controlled if it's not observed.
Yes.
And the reason is this impurity is purged across the process.
Yes.
But no one did the calculation.
Yes.
So you can save money considering analytical testing. How much money the industry using analytical tests by year to just analyze impurities that won't be there because you know about the purge?
I think one of the greatest examples of this is sulfonyl chloride. It's sulfonyl chloride in English?
Yes.
So it hates moisture, it's going to be degraded, and pharma industry loves using water for crystallizations, for washing everywhere. So if you use sulfonyl chloride, it won't be in the final product, and sometimes some manufacturers are testing it, and you're like, why? I know that you use it, but do you really expect it to be in the end?
Yeah. But I think that's the other thing about using the purge approach, right? It makes you think about your process. It makes you understand.
In the process development.
You're not looking down the line going, we've got 100 batches and it's never been hit. But if you do a purge, you know why it's not there.
Yes.
It's actually purged like 3 stages earlier. Final API.
It might be even purged in the step that you used it.
Exactly.
But but it shows that you actually know your process and you know why it's safe, rather than just the analytical test is okay. So I guess
You're trying to pass out the wall.
And ICH mentioned it. You need to demonstrate a good knowledge about your process.
Yes.
Anvisa, EMA, FDA, they request it. You need to demonstrate a good knowledge about your process.
Yeah.
So using Purge, you demonstrate that. Demonstrate consistency and that you know what's happened with each compound in your synthetic route.
And I think that this is what it lacks in the DMS that we analyze. We know like that probably this impurity won't be in the API because of all the process, but they don't discuss about it. They don't.
Well, I think that could be related to education, right?
Yes.
Like we were talking earlier about how we've all got backgrounds in various forms of. At what point are you ever taught about regulations in pharmaceuticals?
Oh, never.
Yeah. What are you taught about? Sort of the levels that you need to control to, and that sort of process of, like, it just isn't done, and people don't have that awareness of. Like, you see it almost in some of the conspiracy theories and stuff that fight around as well.
Yes.
You're like, oh my god, you have no idea how difficult it is to get anything through the regulations. Like, just inclusion of a microchip would never go.
You don't have 5G on your door.
And also when we get in touch with some purge analysis, I would like to see why are you putting this score in this in volatility or solubility. They just put the score and we need to trust them. Like, of course we know we have our background, but it would be nice to see what was your logic behind and why
the Mirabilis report.
exactly. That's where Mirabilis gets in, and I think it's an amazing tool. We should use this one.
Definitely.
It will help us.
Yeah, we both did a couple of purge calculations, but we did it by hand. Like the process was it was an easy process, so we could do it like it was a 2-step something.
But do you know one thing that happened with nitrosamine? At the beginning, purge calculation was accepted to nitrosamine, but some companies delivered wrong assessments, and EMA, just to make sure that there is no nitrosamine there, stopped to accept purge calculations for this. And I love entities that you explain this because it said it's not because a car can crash that you needed to forbid all the cars in the street. So it's the perfect analogy for the situation. And again, I need to talk about Mirabilis. Okay, guys, I will assume here public Mirabilis is my favorite Ultilizá software. There's no discussion about that. And Mirabilis can support you through the assessment, because when we are talking about do by hand, of course we are not talking about do all the calculations by hand. We are talking Excel spreadsheet. And when we have a lot of formulas in an Excel, you know how hard it is to not lose a formula or do not put a cell in the wrong position or do an alteration. Oh, you are doing your assessment and then you remember that no, we have changed the temperature. We now are using 25 degrees and needed to change in a lot of places because we have a lot of impurities. So we have several tables to each impurity. Mirabilis, no. Mirabilis, you have the information at the beginning that automatically is transported to each impurity. And if I change some information for impurity 10, the same information will be changed for the other 9 impurities in the beginning. So it's easiest with Mirabilis. Do not lose track of what is happening with assessment. So it's so much better than only a spreadsheet. And that is amazing how you can save your time checking values, checking if the cell was correct, if the formula was working. With Mirabilis, we make sure of this.
Not to mention for you to go to search for your validate your score. So you need to assess the solubility of something that you never worked with, and you need to check that if your knowledge is in the same page of the score that you're putting in the spreadsheet. So it takes a lot of time from your work. So yes, I think this would be like, for me at least. Sometimes we always get that little voice in the back of our head just saying, "But if, are you sure?
Yeah.
Well, are you sure that this is the correct score? This is the correct solubility that you're assessing?" So yeah.
And here we are talking about education on Purge that Mike mentioned. We do not learn this in our organic class.
Yeah.
No,
So we should start to be learning about it during our PhD, during our master degree, to understand what is happening to the process.
Yeah.
It can be very useful. And this is other thing that I love in Mirabilis here in LASA. Mirabilis works not only as a software, we works like a consortium. So this year we will have a presential meeting again. We had 1 year and a half ago, and we have another this year. And this is when all the Mirabilis users sit and discuss the issues that they have, and we discuss best practices all the time. So we provide the trainings to the members, and we can, Mike, help me here. The member has a question, and I don't know exactly how to answer. What is the best practice in this case? And then we align and discuss, and sometimes we spread the question around the team to get the best answer possible to deliver the best result. So we have this educational side in Mirabilis that's very, very strong.
Yeah, and it's great to hear that it's a collaborative effort. I mean,
Yeah.
everything at LASA
It's
a
all
collaborative-
collaboration.
Yes,
Yeah.
yes. All the development here in LASA is. But in Mirabilis, we do these meetings time by time, and we have this close discussion about best practice. And Mike worked some amazing papers about how to address initial concentration, that is a challenge, solubility, another challenge. So we have some best practice to follow in Purge, and we need to talk more about educate on Purge.
Yeah.
Which we've almost started doing, I guess, is part of our educational charity purpose as well. One of the
Yes.
things I've done
Yes.
is I last year I went up to the Leeds University and gave a lecture to university students all about regulations relating to pharmaceuticals. So we're trying to start the ball rolling
Yes.
on that education piece.
Yeah, because this is something that we don't hear during college or even during grad school. But yeah. Well, we're getting to the end of the episode.
Yeah.
Is there any question that you want to ask?
I just one final question. Like, do you see some perspectives in purge calculation? Like, what would you like to see in the future, other than people contracting consult-lab?
Yes.
That's a good one.
Yeah. I think the probably the biggest one we already touched on is a greater impetus on the manufacturers providing an assessment alongside the API they provide. They are the best position to provide that information. They don't have to do it themselves, as I said, but you would always provide a certificate of analysis, right?
Yeah.
Yes.
Given how important, particularly in the mutagenic area and the nitrosamine area, given how important that is, we should be using that knowledge to its maximum to ensure the safety. So we really do need to get awareness of purge,
Yeah.
and Mirabilis, obviously,
Yeah.
more out to all those manufacturers.
Is the consequence for this is that we can use Mirabilis also in the generic industry to manage the life cycle of an API. So when we have the first purge assessment and we have some changes in the synthetic route by the manufacturer, we can track it and understand better what is the impact of this change in your process. So I can see Mirabilis being applied in generic industry very soon, with purge being spread around the generic industry.
I think that links actually to one of the developments we had in Mirabilis as well, following the outbreak of the nitrosamine crisis. Like if you look up how it appeared to start, it appeared to start from a change in the manufacturing process where they changed a step, which turned out to be a pretty critical step. And people use nitrite to quench azide, right?
Yes.
They're probably so focused on that potential explosion risk
Yeah.
that they did.
It's an important risk. Yeah. They were right.
It's a big risk, but they've potentially then overlooked the subtle risk of the nitrosamine falling, and so that was just a small element of human error, that oversight. But actually, we've now factored that into Mirabilis as well through highlighting it. We know we're controlling it, but every now and again it might be just pop up. Have you considered whether or not this could form? And that could prevent the next crisis, right?
Yeah.
So these are big things.
And I forgot to mention one thing that's
No, go ahead. Yeah, you're
my last comment.
Be our guest.
I just
Mike and I.
got a message that we still have more time, so
Okay. Mike and I, we forgot to mention when we were talking about the pastel queue that we both work at Ultilizá-La.
Oh yeah.
And we work in the same team.
Yeah.
So we work together in Ultilizá-La to provide purge assessment. So it's where we can apply the best practice that we have learned and the best uses for Mirabilis and how to apply Mirabilis to develop a process or to set an impurity profile.
Yeah.
So
And I'll be Maria now because Maria is not here, so I need to
do her
her
role.
Yeah. So Maria always says to us that it's important for the industries to know their process, and and we are not doing a checklist of does it have mutagenic impurities? We think not, so okay. So you gotta really understand what you're doing and to know your process, and this can be applied for almost everything. So for force degradation studies, for everything. If you expect something bad to happen, you better know it, and you better know strategies for control, and purge is a big one. Yeah, I think so.
exactly.
Yeah. And also, like, what would be the challenges for a purge study in an industry like working with unexpected molecules, weird solvents?
Biggest challenge for industry, probably, I don't know, probably resources.
So
Trying to get time to study it. I think solubility is always a challenge.
Yeah.
People don't necessarily measure solubility,
And solubility,
particularly for impurities, right? They might do it for an API because they want to understand the behavior of it. For impurities, it can be much harder because do they really want to spend time actively synthesizing something that they don't ultimately believe is going to be a problem anyway?
Yes.
and getting sufficient amount of impurity,
Exactly.
it's an impurity because it's difficult
Yeah.
to produce
Exactly.
it, right? So yeah.
So that, I mean, sometimes getting that analytical sample to do the confirmatory testing, could well be the hardest part.
It was like nightmare of the chemist.
Yeah.
You just want to get rid of the impurity. Now they are asking you for synthesize it.
And I mean, it's great if you can't even make it. Then you can say, well, it was
Yes.
it was only theoretical anyway, and you can't make it, so it's
Yeah.
not a problem. But I think it's some of the harder ones you see are where it's like a byproduct of a late reaction. It's formed a very close proximity sort of molecular structure to the API in such a small level, and you've got to try and it's not what you were trying to make. You weren't ever intentionally trying to make it, and you've got to try and dig out enough to do something. And build an analytical method, and they look the most challenging. So
And again, this is pretty obvious for nitrosamine, so you don't expect them to be formed in a huge quantity. Some amines are not even really that reactive.
You don't know how is this happening? Like,
not
where
again.
did it come from? It shouldn't.
And we only have a small amount now. We need a big amount to put in an HPLC run and identify
And if you are talking about the purge calculation by itself, we can observe that is a challenge to assign the initial concentration. Sometimes it's obviously, but sometimes it's not, and you need to understand how you can assign the initial concentration. If you are adding, it's easy. But if it's formatted in the middle of the process, we need to think about how it's the best way to address what is the initial concentration. And the solubility, as we mentioned, is always a challenge. It's always a challenge. But also, I forgot what else to say, but for sure, initial concentration is a challenge.
Do we have some best practices?
Funny you mentioned that. I was on a call yesterday, just discussing this very thing. So yeah, watch this space on that one.
Okay, right, cool. Yeah, that's good to hear.
Next steps, but we have some general orientations about how to proceed with this. If you are using excess reactant, and how you can consider the initial concentration, but of course, there's several different situations that could be applied. So this is one of the main. And other thing that now me come back to talk about Mirabilis, my boy.
Don't worry, go ahead. That's all we want to hear.
That's your time.
One thing that happened when you are developing a process is that you do not consider it all the byproducts that could be formed. And in Mirabilis, we have a tool that can predict it for you if some compound anitrosamine can be formed by carry an impurity into 3 steps to the steps that we are evaluating now. So, for example, we introduce the amine in the first step. In the third step, we have a nitrosate agents and an acid environment. What will happen with this amine? You may not consider this during your first assessment, but Mirabilis will show you here this structure is possible. And this is an amazing tool that we have in Mirabilis.
Is Mirabilis tied together with Zenith in a way? Like, is the knowledge base the same to...
No, it's a different knowledge base.
Okay.
A lot of it ultimately it relies on chemistry.
Yeah.
Uh-huh.
It's all chemistry.
Chemistry. But given that theirs is much more focused, Zenith is much more focused on the drug product, you've got sort of, I guess, a different area of chemical space.
Okay, right. Yeah, it makes sense.
Whereas Mirabilis is much more focused on sort of classic in-solution chemistry rather than anything else. So they're trying to focus much more on potential mechanisms that are either observed in degradation studies.
Yeah.
Whereas we're just, let's get a Suzuki.
Yeah, I think photochemistry is not really that important for part calculation.
Yeah, exactly.
Yeah. And I remember now what was the other thing that I was to talk about. When there occurs some reprocessing, always the member come to us asking what's the best way to calculate purge when there is a reprocessing. And here you need to evaluate the level of this evidence that you may have. If you do some control in the model record that you are putting back in the process, and what kind of control you may have. So it's case by case, but it's a bit tricky, and you need to pay a lot of attention in how to do it. It's a challenge in purge calculation.
Yeah. Is Mirabilis capable of predicting isomer impurities?
We've generally steered clear of most isomers.
It makes sense. Yeah,
because I mean it could get crazy, right?
Yes.
We're not trying to make things harder than they need to be.
Yes.
Yeah,
That's
yeah.
great.
If you've got four like chiral centers, we could potentially end up predicting 16 different ideas that you have to now that you now have to manage. And is that really the best use of people's time?
Yeah.
It's
true.
That's important too. Do not overcomplicate purge calculation.
Yeah. I used to work in my master with a molecule that had so I used ibuprofen. So ibuprofen it was a racemic mixture, and my carrier it was a prochiral molecule, and I had to attach 2 ibuprofen molecules to this carrier. And so sometimes could be R ibuprofen, S ibuprofen, and they would activate the prochiral center, and then I would have like different diester isomers it gets tricky. The NMR gets chunky with a lot of signs. So it's also
I mean, it still has to be considered though, right?
yes.
In terms of the safety, those isomers will need, but if we then start predicting potential byproducts of those isomers, we're not just it could explode. Like you could have so much to do, and actually then that inhibits your ability to focus on the core problems.
But maybe isomers might not be a huge concern when we are talking about purge. Just thinking out loud, it's because you're usually looking at 1 or 2 molecules, so maybe it's justified to have like a proper assessment in the end in this case, because it's only 1 impurity. So maybe purge and calculating purge for in this case can
it's already hard to purify it, so
Yeah.
to make the
definitely.
conclusion
Yeah.
of purging. So
I think my final question was not really a final question because we went around it a little bit, but it's great to hear from you both, and I think, well,
I'm pretty sure.
yes, and we are really prepared now to I think we're a lot more confident now to do purge calculations.
That's good.
Yeah. And we were already confident, but now I think there are no doubts anymore that it's a viable strategy, and it can be used for almost every single molecule. If you can apply purge calculation, do it. There's no reason not to. Yeah.
Exactly.
Yeah.
Ultimately, it always needs somebody to take the first step, right?
Yeah.
If regulators start seeing it from lots of people, and they're done correctly with best practice, they see that it works and it's applicable.
Yeah, and regulatory
And
agencies accept it. Yeah, there's no reason not to. Yeah, it's even on ICAJ PM7. So
Exactly.
yeah.
And it's important when you are starting to learn about purge, go to the most important papers and come back and discuss it with who has more knowledge, and come to Laza's webinars and the Spektra webinars that I heard that will start to come in this year. So the idea is learn about purge is not a big monster. It's something easy to be applied and improve the safety of your final API.
Yes, sure.
Whilst making your own life a bit easier.
Yeah. Situation. That's perfect.
That's always the key, right?
Yeah.
It benefits you as well.
Your process might be cheaper and the drug might be safer, so
Why
I
not?
thought just go ahead. Yeah.
Yes. That's what we try to do here with our podcast. Try to get experts in the matter to talk about in a way that people see that this is interesting. This is not that hard. I can get better on this on this matter. So thank you both for your time and for our chat here, our talk. It was a great scientific conversation, and I was looking forward for this episode. Mainly both of me and Lucas, we came recently from the lab. We're now getting to the desk table, and I'm pretty sure that everybody will love this episode. And thank you for your time. And do you have a few more considerations?
Well, no, I just gotta say that chemistry talk can be a little bit nerdy, but when you got
I think we've largely skirted around that.
but when you got 4 chemists, I mean the interaction is great. And
We're all friendly chemists.
And thank you for inviting
Yeah,
us.
thanks
It
for the
was a
invitation.
pleasure.
No worries. So now we're going back to Portuguese again to close our episode. Então, pessoal, hoje a gente conversou com o Mike e com a Roberta aqui da LASA para falar a respeito da análise de purga e também do Mirabilis, que é o software da LASA para avaliar a purga de maneira geral. E a gente entrou em diversos tópicos relacionados quão importante é a purga, como que ela pode ser utilizada, quais são os desafios dela e como que são as perspectivas a respeito da purga e também da utilização do Mirabilis como ferramenta para avaliar esse processo. E foi um episódio bem proveitoso, espero que vocês todos tenham gostado e que vocês considerem essas informações importantes para o dia a dia de vocês. Você que está vendo pelo YouTube, só lembrando que você pode ativar as legendas aqui embaixo na barra de ferramentas do YouTube do próprio vídeo, e aí você pode ativar as legendas para você conseguir acompanhar melhor o episódio e ficar mais claro o que a gente conversou aqui. E agora eu vou deixar para o Lucas fechar aqui o episódio.
Bom, então, gente, realmente foi um grande prazer ter vocês aqui nesse episódio. A gente trabalhando aqui na LASA, mesmo que por um tempinho breve, é realmente muito marcante. E, como o pastor dizia, o acaso favorece as mentes preparadas. E eu espero que esse episódio tenha sido o acaso que você estava precisando. E até o próximo episódio. Tchau!
Tchau! Comes to the prepared minds.
Yeah, favors the prepared
minds.
Yeah.
And so we finish our episode saying this, like Pastor used to say.